LCHL higher level question 5 in 2019 was a complex numbers question dealing with complex roots, deMoivre and polar form. In part A, we're told that 3 plus 2i is a root of z squared plus pz plus q is equal to 0, and p and q are an element of real numbers. Now, we have real roots, or actually complex roots, where p and q are real numbers. We can use the conjugate roots theorem. So if 3 plus 2i is a root, 3 minus 2i is a root. Now, let's have a look here. Any quadratic equation can be written in the form z squared minus z or x squared minus x times the sum of the roots plus the product of the roots. So what does that mean? That means that if we add the roots together and change the sign, we can get this number, and if we multiply the roots, we can get this number. Sum product. So let's add the roots really quickly. We get 6. The 2i's cancel and the minus 2i cancel. So we're going to get z squared minus 6z and then plus q. So the product of the roots. When you practice these questions a lot, you'll see that we're just going to get 3 squared minus 4i squared, which is going to be 9 plus 4. But if you want to write out in long form, they tell you always in the complex numbers question that I squared is minus 1. So 9 plus 4 is equal to 13. So my equation becomes z squared minus 6z plus 13 equals 0. Now let's just use the quadratic formula here to verify this. Minus b is 6 plus or minus the square root of b squared, which is 36, minus 4 times a, which is 1, times c, which is 13. All divided by 2 times 1, 2a. So we're going to get 6 plus or minus 36. 36 minus 52 is 16, minus 16 over 2. So we're going to get 6 plus or minus 4i. Square root of minus 16 is the square root of 16 by the square root of minus 1 over 2, which you can see is 3 plus or minus 2i. So that's where this comes from. An easy enough question using that method when you know how to do it. So, writing a complex number in polar form. Let's have a look. Let's sketch where it is. We don't need to worry about the scale 2, so positive, negative, so 2 and down here. So that's the point, or the complex number v, which is equal to 2 minus 2 root 3i. Now, let's draw our right angle triangle here. We've gone out 2 on the x and we've gone down 2 root 3 on the y. Let's call this angle A. The angle that we're looking for is starting here and going all the way around to the modulus, which is going to be r. So let's get r. R is equal to, it's just Pythagoras, 2 squared plus 2 root 3 to be squared. R is equal to the square root of 4 plus 2 squared by root 3 squared is 12. So the square root is 16. R is equal to 4. Now let's work out our angle A. We have our straight sides. Well, we also have our diagonal, but let's use the straight sides. Tan of A is equal to O over A, 2 root 3 over 2. And these normally work out straightforward enough. We know that the tan of 60 is equal to root 3 and the tan of 30 is 1 over root 3. So A is equal to 60 degrees. Now we look at the question. They tell you that theta, our angle, this green angle theta that we're going to get, is between 0 and 2 pi. So they want the answer in pi form. You can use degrees, but let's write it in pi form. So we know that pi is 180, so 60 is 180 divided by 3. So that's A. Now the angle we're looking for, theta, is, if we came all the way to here, if we came all the way to there, it'd be 360. So it's going to be 300 is what we're looking for. And you can see the relationship between the two. That's 5 of the one above, or 5 pi over 3. So we can now write our complex number in polar form. It's going to be 4 by the cos of 5 pi over 3 plus I times the sine of 5 pi over 3. And you could you can change your calculator to radians to check that you get 2 minus 2 root 3i, or you could use degrees to check that you get 2 minus root 3i. 2 minus 2 root 3i. So in part 2, you're going to use your answer from B part 1 to find two possible values of w, where w squared is equal to v. Now we have v as our complex number. So write w squared is equal to 4 by the cos of 5 pi over 3 plus I sine 5 pi over 3. Now I'm going to change it to degree form. We can change it back if we want at the end. I just think people seem to find it easier to do these things in degree form. 300 degrees plus I sine 300 degrees. So if we want w, we're going to get the square root of the other side. And we know from deMoivre that the square root number or the power goes here and here. So that's going to be the cos of a half times 300 plus 2m pi for my multiple solutions. Now n is going to be 0 in the first instance, so we're not going to need the 2m pi, plus I times the sine of a half times 300 plus 2n pi. Now a good way to do this, if it's to the power of a half, we're adding 180. If it's to the power of a third, we're adding 120. If it's to the power of a quarter, we're adding 90. And nothing else really comes up within these questions. So practice these questions and they'll be the easiest question that you do in the exam. So let's look at w now, when n is equal to 0. We're going to get 4 to the power of a half, which is 2, by the cos of, now it's obviously not the same answer as the first one was 300. This one's going to be a half of that, which is 150, plus I sine 150. And we're looking for two possible values of w, so we'll multiply that out now in a second. Well, let's multiply it out now. So the cos of 150 is minus root 3 over 2, and the sine of 150 is going to be a half. So what do we end up with? We end up with the first solution for w is minus root 3 plus I. It's the first solution. When n is equal to 1, we're going to add on 2 pi by a half. So we're going to get 2 by the cos. We write it in long form. A half times 150 plus 2 pi, which is 360, plus I times, and you should be able to see what this is and do it a shorter way, 150 plus 360. Sorry, apologies. I should have, if we're going to do it in long form, and it's probably easier to do it the other way, 300 plus 360 and 300 plus 360. So it's going to be twice the cos of half of 660, which is 330, which is 180 added to the 150, and then plus I sine 330. So using your calculator, the cos of 330 is root 3 over 2. And the sine of 330 then will be minus a half. So we're going to get root 3 minus I. So our two solutions are root 3 minus I and root 3 plus I.